Okay, now we're going to look at solving inequalities with multiplying and dividing. We've already done adding and subtracting, and we found out that the properties of equality hold true for inequalities as well as equations. So let's take a look at multiplication and division. So here is an example problem. Go ahead and read that and then continue with the video. Alright, if you've read this so you get an idea and maybe copy down the chart and some of the more important words and questions, let's take a look at the two questions A and B. If you divide each side of the inequality 300 is greater than 50 by 2, is the inequality still true? Well, if you divide 300 by 2, you get 150, and if you divide 50 by 2, you get 25. So 150 is still greater than 25, so that would be true. So the answer is yes. And explain using an inequality, it would have 150 is greater than 25. Would the weight of 5 astronauts be greater on Pluto or on Earth? So if you multiplied both sides by 5, Pluto and Earth, so Earth would be 1500 and Pluto would be about a little over 300 or 400, then you have Earth would still be the greater weight. And explain using an inequality. It would be 300 is greater than 67, therefore 5 times 300 is greater than 5 times 67. Okay, so copy these notes down. This key concept, the big picture thing is that when you have a number that is greater than another number, then if you multiply by that same number, it's going to keep that same inequalities, or if you divide it, it's going to also. So it doesn't matter whether you multiply or divide. In this case, 2 is less than 6. If you do 4 times 2, it's still going to be less than 6 because 8 is going to be less than 24. If you divide by a positive number, then 3 divided by 3 is 1, and negative 9 divided by 3 is negative 3, and 1 is still greater than negative 3. And the same thing, the blue, here in blue it says A is greater than or equal to B, and A is less than or equal to B. So it still holds true for that also. Alright, so let's take a look at some examples. We have 8x is less than or equal to 40. So if we divide both sides by 8, and again we show it as using the fraction bar and then dividing by or partitioning by 8, then x is less than or equal to 5. And you can check this solution by picking a number that is 5 or less than 5, and it should still fit or keep the sentences true. For B, it's the same thing. If we start with a division problem, D divided by 2 is greater than 7. Then we can multiply both sides by 2. 2 over 2 equals 1, and that's why we're just left with D. And 2 times 7 is 14. So if you want to test this, pick a number greater than 14 and plug it in. Plug it into here, and you should get a true statement. Alright, here's where the catch comes in, multiplying or dividing by a negative number. What happens when each side of an inequality is multiplied or divided by a negative number? Well, if we start off with negative 6 is less than 11, let's say that we're going to multiply each side by a negative 1. So if I multiply negative 1 by negative 6, I get positive 6, and if I multiply negative 1 by 11, I get negative 11. Well, 6 is not less than a negative 11, so this is false. Let's try it again over here. 10 is greater than 5. Let's say we divide both sides by negative 5. So 10 divided by negative 5 is negative 2, and 5 divided by negative 5 is negative 1. Well, negative 2 is not greater than negative 1, so this is also false. So the inequalities here are both false. However, they would be true if you could reverse the symbols. So we want 6 to be greater than negative 11, which is true, and we want negative 2 to be less than negative 1, which is also true. So if that's the case, then we have to amend our properties when we're dealing with negative numbers. So go ahead and write this down. When you multiply or divide each side of an inequality by a negative number, then you have to reverse the inequality symbol for it to remain true. So notice what they're doing here. I'll go ahead and get my highlighter. So you have to reverse. This is the key here. Reverse the inequality. Oh, the inequality symbol must be reversed. We'll do that. Okay? So here you have 7 is greater than 1, but if we're going to multiply both sides by negative 2, we have to switch this inequality. Okay, so you have to reverse it so that negative 14 is less than negative 2. Same here, if we have negative 4 is less than 16, which is a true statement, and we divide both sides by negative 4, we have to again reverse the inequality symbol so that when we get our answer 1 is greater than negative 4. And that is also true for, obviously, for greater than and equal to, greater than or equal to, or less than or equal to. So just to make sure you understand, go ahead and do the concept check. Explain why it's necessary to reverse the symbol when you multiply each side of an inequality by a negative number. And that's because you've got to be able to keep that sentence true, since it is a property of equality, so we have to reverse that symbol. Alright, so let's check this out. Multiply or divide by a negative number. Solve each inequality and check your solution, then graph the solution on a number line. And here's another way you can prove that you do have to flip that symbol. So some number divided by negative 3, find my cursor, some number divided by negative 3 is less than or equal to 4. So that means I need to undo the division by multiplying by negative 3 so that my x is positive. But when I do that, here again, I'm going to highlight it, you need to make sure you flip that inequality symbol so that negative 3 times 4 is a negative 12. So my answer has got to be x is greater than or equal to a negative 12. And when I graph it, remember close point, and then everything to the right. So let's say that I pick a negative 9. Okay, so negative 9's in my range right here. I'll go ahead and put a big blob there. So if I plug negative 9 in here, negative 9 divided by negative 3 is positive 3, and that would be true. Positive 3 is less than or equal to 4. Okay? Here's another example. Negative 7 times a number is greater than negative 56. If I divide both sides by negative 7, again, they switch, so don't forget to switch this, and I get positive 8. So x is less than 8. So when I graph this, it's an open point, and then you pick any number less than 8. Here's my favorite again, 0. Okay, so let's pick 0. Well, negative 7 times 0 is 0, and 0 is greater than a negative 56, so that would make a true statement. Alright, here are your practice problems. Make sure you use the guided key practice. If you're stuck on exercises 4, 5, and 7, then go back to example 1. If you need help with 6 and 8 through 12, then look at example 3. And if you need help with exercise 13, look at example 2. And then continue this video to see the answers. Okay, and here are some of the answers. If you have any questions, please write them down, bring them to class, and discuss it at your table groups, or come and see me. All right.